Today I will show you how you can deploy an Elixir, actually Phoenix application to Fly.io and scale it across different distant locations, and how they actually make it work. So I will base my examples on a Pento app. This is something that you build when you read this book, and it's just a regular Elixir Phoenix app with some live view components, and it just so that you understand where the Pento names come from. I don't know why it's Pento, but this is how they call it. Anyhow, so to launch and deploy an Elixir Phoenix app into Fly.io infrastructure, all you need to do is to run fly launch and give it a name. Fly is the fly command line is the Fly.io command line tool that you can install on any system, and you can just use it to manage an infrastructure that they have. So with this one, some scanner comes into your you run it in your Elixir project, and it gives you some defaults like what VM you will be using, what's the name of your app. Mentel as Pento is just the name of my app, and then it also detects that you have Postgres in your project, and it will spawn a Postgres application for you. So I accept the default, and what happens here is that first of all, a release like Erlang release or OTP compliant release is generated with mix release in it, and Docker file is generated for your project. So so-called scanner scans your source code, detects different settings, and creates a Docker file that basically encapsulates your app. And then a Docker image is built, pushed into the Fly.io infrastructure, and then from that Docker image, a micro VM, more specifically Firecracker micro VM, is run onto the infrastructure on a VM. And in the meantime, there's also a release command running in the background, just migrating your database. And because the scanner detects the Postgres, it also sets up the database URL. So it's pretty neat how easy it is to run an Elixir system. And a fly app, the Mentel as Pento that you saw in the beginning, is just a bug for all the resources that you need to deploy something, like the machines, IP addresses, volumes, configuration, parameters, and this kind of thing. And when it's done, we will get two machines for high availability. So when you are requesting your app, the request will be load balanced between the two machines. And by default, you get a fly proxy, so just a load balancer in front of your app, and then it manages the requests. What's also a cool thing is that by default, you get auto start and auto stop capabilities, meaning that when there's no traffic, the proxy would stop your machines, and then when traffics come in, hits your system, it would basically bring the machines up again. So this is still running, so let's speed it up a bit. This is a recorded demo. It's a safe one. So now what I'm doing here is I'm using FlyApps list to list my applications. As you can see, there are two of them. Mentel as Pento is the one running my Phoenix app, and the other one is the database. And then when we move on, what I can do now with fly status, I can get some pieces of information. What's interesting here is that my machines were deployed to Warsaw because that was the closest data center that Fly operates. And then finally, with Fly logs, I can see some logs. That's not that interesting. But at the end, here I wanted to show that the load balancer would actually spread the load across different machines. You can see 14 here and then 17 here. These are the IDs of the machine. And finally, with SSH that I will hopefully run successfully, I can get into the remote shell of my Elixir app. And now with node list, I can see that there is just that I'm already running a cluster because I have a node on that list. and that cluster get formed automatically, and this is because we have two machines from the very beginning by default, and they are clustered for the high availability. Okay, and now how to scale this thing into multiple locations. So to do that, you use, my demo got broken even though it was recorded. Give me one more sec. I'm doing fly status again, and here you can see that one of the machines already got stopped. If we still waited a little bit more, the other one would get stopped again. When I hit the up, it would get started. And now I'm scaling my, my system to 3 regions. And what I do here, I just call execute fly scale count 3, meaning that I want my app to be running in 3 locations. And I'm saying at most 1 VM per region, and finally I'm specifying the list of regions I want to run in. So I say I want one app in one instance in LAX, which is in Los Angeles, the other one in Warsaw, and finally one in Sydney. So when I do it, I'm presented a plan which says remove 1 machine from Warsaw and add the other 2 in the other locations. And it's executing, and now my system is running across continents. And now I'll be doing a few things to actually see some details. So I'm logging into one of my nodes, and I'm getting the list of the node list. I'm getting the list of nodes, and I'm doing the ERPC call, and I'm sending an anonymous function that will retrieve fly region environment variable so that I can read from those nodes' perspective where they are running. So fly region is the environment variable set on each VM, and obviously you can read it from your Elixir or Erlang node. And as you can see, I'm running in the expected locations. And I can see that 2 nodes on that I'm clustered with 2 nodes, and my local region is Warsaw. Okay, and finally, if you test, I tested my app with this kind of site that tells me what's the round trip time from different locations to my endpoint, and you can see that it's quite fast from Frankfurt because it's close to Warsaw. It's very fast for Sydney, and the closest one to Los Angeles is probably Chicago. It was somewhere where it is. It's here, so it's. I expected it to be shorter, but it's still under 300 milliseconds. And for example, from Hong Kong, it takes almost a second to hit my endpoint.
These are times to the closest instance.
So when you look at this line, it means that a GET request was run from Frankfurt, and it picked the closest region, yes, because that's on the Anycast, to be more precise. So what we've got here is that with fly launch and fly scale, we've got 3 fly machines, because this is how they call the VMs, and they are all interconnected with a private IPv6 network. They call it 6PN, and they form a cluster. And it seemed, at first glance, it seems that it's pretty easy, but there are many interesting details how they achieve it. So I will start with a clustering basics, so that we have a good ground to start. So when you want to cluster 2 Elixir or Erlang nodes, what you have to do is you first have to start one node with a name, either S name or name, just to enable the distribution facilities, so to speak, within an Erlang or Elixir node. And then in the second shell, I'm calling EPMD minus names. EPMD is the Erlang port mapper daemon, which is like a nodes registry. So when your Erlang on Elixir node starts in a distributed mode, it would register itself within EPMD, meaning that it says, hey, I'm here and I'm listening for incoming connections on this port. And then when I start yet another node on the same host, like B, then I can do node connect A at work. So A is that node, and work is my host name. And now these two can connect because of the EPMD, and because this node knows how to resolve work. It resolves to localhost basically. And now in the first node, I can see that B is I'm clustered with B. And to look at the details a little bit more, this is the debug log from EPMD, and I won't go over it. What's interesting here is that at the very end of this log, we can see that EPMD got port 2 request, and this is where node B asks for a port on which node A listens so that it can connect, and EPMD returns the port in the response. And it is kind of, can you actually read it? It is based on the, at the very bottom, node B is able to resolve the work host name by calling inet get host by name, and it resolves to localhost, the loopback interface. And it all works great on a single node, but now when we have a dynamic cluster, we have some challenges that we have to address, like nodes joining and leaving the cluster because we scale it up and down, or because the machines stop or start because we are scaling down to 0. And host addresses are not known ahead of time. And those are the challenges that a provider like Fly.io has to solve in order to form dynamic clusters. So how to do it? Let's try to address this problem. So first of all, let's have a look at the IP addresses of our machines. So this is a list with machines IDs that are running our Elixir nodes and the IP addresses. And when we SSH into one of the machines, what we can do is to use special Fly.io internal DNS domain, mentel.internal, so upname internal, and when you ask for the quadruple A record, you will get all the IP addresses of the machines that are within your app. So basically, when you create a new machine within your Fly app, then its IP address is recorded and is present in the DNS record that you can query and get the list of the IP addresses. Okay, and now how to do the same from Elixir, because if you want to cluster our Elixir node, we have a way to get those addresses from the Elixir shell. And so let's try that from the Elixir shell. On our way there, we can check the EPMD. So we can see that some local node is registered with EPMD on certain port. And now if we if we start the remote shell, we can use the same inet get host by name API, but this time, because we are dealing with IP6 addresses here, we need to pass the inet6 option, and we get a list of IPv6 addresses, and those are this is a strange format, but these are 8 2 bytes segments, and if you use the N2A inet.n2a function, you will get a string representation. I was trying to find what the N2A actually means, and I think it's the network format to ASCII format. Am I correct? I was trying to look it up, looking at some strange Microsoft docs. Somehow it's a very old API, and apparently I thought it's a network to ASCII format. Anyhow, so that's how you can, from within an Elixir node, that's how you can query the DNS and get those IP addresses. And now let's imagine that if we know the name part of our nodes, we would be able to cluster with one of those nodes because we have the host the host part of the address. We're just missing the first part, which is the node name. Okay, so as I said, the DNS gives us the host part of the node name. Node name consists of the of the name and the host part, and now how we can get the name. So the idea is that the name can be static across all the nodes within the cluster. So they solve it the way that each node within our app that is part of the cluster is given the same name. So this is an example. So my nodes within my app are named like this. So Mentel as Penta, some string, and then the IP address, and only the IP address is the only part that differs. And this is achieved with the env.sh template file. So basically, we export release node environment variable, and then using some fly-specific environment variables, we form a node name. So in the name part, we have fly app name. So that's the Mentel as Pento in my case. We do some bash magic to fly image ref. That's the name of the Docker image. And in the host part, we use the private IP address. And this file is the env.sh EEX is a standard file that is evaluated each time a release starts. So because of that, those variables can be dynamically evaluated, and the release node is set, and this is how your Elixir or Erlang node is named. So to quickly recap, what we've got here is that we scaled our Elixir application to run nodes in 3 different locations. These are clustered with IPv6 address, and this is all based on DNS and some tricky variable handling, so that this process can be automated. And at this point, you probably have an idea how you could write a code that would actually make it possible to automate the node connect thing that you saw in the first slide when I was doing a small recap of the clustering concept. So now let's have a look at how it works with the DNS cluster library. That's a library that is added by default as a dependency when you create a Phoenix project, and they use it as Fly as well. And it actually implements that auto clustering based on the principles that I have just shown. So basically, to use it, you have to add the DNS cluster into your supervision tree, and you configure your query. And the query is what the library we use to get the list of IP addresses of other nodes in the cluster. So in our case, the cluster query is this, because that's the special DNS domain which contains the quadruple A record with all the IP addresses. So it uses the fly app name, and it's in the same env.sh file that is evaluated each time a release starts. And the DNS cluster assumes that the name in the name host is the same as at the current node. So when it runs on the current node, it already knows the name. So finally, some code from Elixir code from the DNS cluster library. So the essence of it is that every X milliseconds, given the list of IP addresses that we got through the DNS query, we map over it and we form the node names, because we know the base name, we know the IPs. Then we filter out the names that we already know, because we are clustered. When the cluster is dynamic, it means that some nodes join, some nodes leave. So we have a set of known nodes. And then for those we don't know, we just spawn a set of tasks that just do connect node. This is underneath just node connect, it's just an abstraction called resolver. And that's basically it. That's how it works. Thank you. If you have any questions, that's the time. And I'm looking for a new job. If you have something, that's my LinkedIn. Thank you.
Is there a way to customize the Docker image?
Yes.
If you need some special stuff.
Yes, so what they do by default, they will just generate a default one for you. So you can either provide your own, or you can, you have a they will create a Docker file directly in your project directory, so you can modify it at will.
Okay, and the second question regarding the scanner, what if you need something that, well, I don't know, scanner fails to identify? Is there a way for manual configuration with some RC file, I don't know, with what you need for the infrastructure?
So basically, the scanner would just detect some basic things like, if there's a database URL and some ports, like very basics, like the database, the very basic stuff, database ports. And if you need anything custom, the scanner obviously won't do that. So you have to do things manually. It's just, so the whole idea of the scanner is to be able to start up quickly, so that if you have a standard Phoenix project, you can spin up a VM just with a single command, and then you have to customize manually. Question from the back.
Yeah, I wanted to ask, you showed us how it magically scales into multiple instances, but you also mentioned the P word, or Postgres. So what happens with the database when I scale to 3 instances?
That's a really good question. I don't remember what's the current state. I think that at the time of recording the demo, they would just you would just use that single instance. You have to scale Postgres manually, but Postgres was in works when I was still there, so it might have changed. So you would have to check. But my guess is for now it would just be one instance, but that one instance is still reachable within the IPv6 network because it spans over all of your apps, so everything can talk to everything.
It's probably gonna be closer to at least one of your nodes, right?
Yes.
So, on the latency screenshot, we could see that the latencies between some of the locations are close to a second, like 700 milliseconds, for example. It also means that the latencies between the different regions where our app is hosted are probably close, more or less, not necessarily these, because these are from the endpoints. So is there some tuning to the distribution protocol, to the runtime parameters or anything like this necessary to get the Elixir Erlang cluster running and not failing with such latencies? And is it also visible in our project when we run our application in some of the scaffolded files or anything? Or is this the secret sauce by Fly.io?
So to be honest, I don't know if they change anything to those parameters, so that, for example, you are not getting false positives of members of the cluster like disappearing. So I haven't seen anything to be tuned. I would guess that would be something
There's, for example,
to do yourself. Yes.
So I'm wondering about that.
When I just today checked if, I checked what the scanner did to my project, and it hasn't done anything to like those net tick time settings or this kind of things. So I don't think that they do anything manually. And I
asked this question on the last Elixir Conf to one of the Fly.io presenters, and the answer was that they are using the default. However, if those Docker images are customized, then you can play around with parameters by setting them as you wish. But the answer was that it is fine with defaults.
Thank you.
By the way, I'm hiring if you're interested.
Later. Thank you. Okay, that's it. Thank you once again.